Yeah.
3, 2, 1. Action.
Bismillahirrahmanirrahim. Assalamualaikum and very good morning. I beg to all my friends and my dearest tutor. Okay, for the first one, today we are going to talk about the stereoisomerism. So what we bring to our table today, we are actually get two organic compound, which is 3-chloro-2-butanol, and also we got also butane 2,3-diol. So what we are going to present to you today, so we actually basically are going to present to you about the structure, about all the type of stereoisomers that we can get from these two organic compounds, and also we can see how they actually presented in 3D notation and also so on. So the first one, we get here butane 2,3-diol. So basically butane 2,3-diol is a compound that actually have two hydroxyl group, which means we got OH and OH bonded together at carbon number 2 and carbon number 3. Due to the fact that we are going to use we can actually look, there is actually two chiral carbon inside this compound. Then using the formula of 2 power of n, so we get actually 2 power of 2, which is mean actually 4 stereoisomers. But we need to actually notice that there is meso compound in this arrangement. So what is meso compound, guys? Meso compound is actually stereoisomers, or actually a structure that actually have identically resemble each other in asymmetrical plane. So we can actually see here is that when we divide, or when we are going to put the symmetry line, so we actually get the same identical structure in two of the half. So actually, the second one, before going to the isomers and enantiomers, we actually are going to talk about 3-chloro-2-butanol. So I would like to invite one of my friends to actually discussing about 3-chloro-2-butanol. So,
okay, so this is 3-chloro-2-butanol. So why we call this structure 3-chloro-2-butanol? Because okay, we'll start from here. This is the first carbon, second, third, and fourth. So this is we call it as 2-butanol because the OH group is attached to the second carbon, and then there is this group which is chlorine, okay, attached to the third carbon. Okay, so how do we determine whether this is which is the chiral carbon? So first of all, we look at the the second carbon is chiral carbon because it attached to 4 different atoms in group, and then the third carbon is also the chiral carbon because it attached to 4 atoms of different groups. Okay, so this molecule actually has stereoisomer, and this is a chiral molecule because it does not has plan of symmetry. Yeah, because we cannot divide this molecule into 2 and get the same division. So it also has 4 stereoisomers due to the fact that due to the fact that it has 2 chiral carbon, because 2 to the power of 2 is equal to 4 stereoisomers.
So that is all about the structure. So do you know actually what is meant by chiral? Chiral is actually as a Greek word means hands. So actually chirals in Greek means hand. So chirality is basically how we are going to actually determine how the compound is actually superimposable or non-impossible. So in order to understand that, we need actually to draw a facial projection in order to understand all of that things. So for the 3-chloro-2-butanol, so we got actually 4 stereoisomers that we can get. So actually the first one, okay, we can look here, the first one. So the first one and the second one actually is a mirror image to each other. So what we actually, and they are also non-superimposable to each other. So when they are non-superimposable to each other and they are also a mirror image to each other, they are called enantiomers. So that explains the one and the second one. Okay, for the third one and the fourth one, they are actually also a mirror image to each other. So we call this as enantiomer. So what actually we mean by their stereomers? So one of my friends, can you explain how the stereomers work?
So diastereoisomers ni, so basically dia adalah bukan yang mirror image towards each other. So yang bukan mirror image kepada antara sama lain adalah 1 dengan 3, 1 dengan 4, 2 dengan 3, 2 dengan 4. Itulah untuk yang diastereoisomers.
So basically, diastereomer is mean by they are non-superimposable to each other and also they are non-mirror image to each other. So we are going to the butane 2,3 diol. So this is the first one that we need to understand. When we are using the formula of 2 power of n, we actually can get 4 stereoisomers, right? But then we need to actually understand the structure very carefully because in this structure, they are actually a meso compound. So basically, can my friend actually explain to that?
For the butane 2,3 diol, we will have, if we use the formula, we should have 4. But then, we should only have 3 because we will have the number 1 and number 2 we have as, we call it as enantiomer because they are mirror images. Then, for number 3, it's called meso compound because, because first of all, it has plane of symmetry. Then it is called meso compound because if we rotate it 180 degrees, it is identical. So we put it as meso compound.
So basically, what is mean by meso compound? Meso compound is when the organic compound is superimposable and also they are actually mirror image to each other, they are called meso compound. So that's all for today. So we actually, in conclusion, we actually have explained to you that the butane 2,3 diol and also the 3-chloro-2-butanol is an organic compound that actually have various various amount of stereoisomers that we can understand. So that's all from us. So thank you.